Hello, work together, friends. We are up. I don't have any viewers left, but viewers on yet. That's okay. That's all right. Yeah. So I'm gonna try to keep this kind of brief as possible tonight. But our subject tonight is CSS transforms. I'm gonna go ahead and ask my wife to turn the TV down because it's a little loud over there. So give me just 1 second. Sorry about that. Okay. So CSS 3D transforms. Let's make that happen. Okay. So, right. Okay, so this is I want you to remember back to the point where someone explained to you how Game of Thrones was. HBO, okay. It's based on a series of fantasy novels. What? And it has dragons. Okay, I don't know that I want to watch that show. So there's a lot of people who had like a really hard time explaining the premise of Game of Thrones and then knowing how awesome it would be, which is why the Battle of River Run never got a budget. We never got to see it. But what I am going to do is I'm going to explain CSS3 transforms a little bit, and I'm hoping you'll kind of be on board with me long enough to see how awesome it is, right? I had a similar thing when my wife and I met. She had never seen Firefly, and I was like, it's a show. It's a space western. And she was like, I don't know that I want to watch that. And I was like, just watch the first episode. If you don't like it, you don't have to watch anymore. We ended up watching the entire first season. Well, the entire season, the entire series, because it's just one. So yeah, CSS3 transforms. Transforms use transformation matrices to change the appearance of shapes. They are composable, animatable, and they only change the appearance without kind of changing the displacement of things. It's a really easy way to get some really cool visual effects going. So before that, I have to explain like just enough linear algebra, like just enough. So just kind of bear with me for a moment. And I'm going to try to just kind of explain this in block form so you can visualize what's happening. Okay, so a matrix. A matrix is basically the sort of square of numbers where each cell is a number. This is a 3 by 3 matrix. Okay, and you can multiply two matrices together. And it's kind of a weird operation. What basically happens is that first one and the second one, and well, each cell in the third one and the one that you create, it kind of corresponds to one row of the first one and one column of the second one. And you basically take the first row and the first one of the second column, multiply those, and then take the seconds and the thirds and the however many's. So the thing in that spot is a times j plus b times n plus c times p. Okay, and then what would go in the one to the right of that would be the ABC row times the KNQ vertex. So it would be AK plus BN plus CQ. Again, I'm going to kind of hand wavy. If this doesn't make sense, that's fine. We'll get to the superpower part in a second, right? Okay, so that's how they get put together. And why are they useful? Well, if we have a matrix like this that has some values A, B, C, D, E, F, and then 0, 0, 1, and we have some vertex, some two-dimensional vertex, X, Y, and 1, why, and the reason that's a 1 and a 0, 0, 1 is just reasons. But what we end up having is we have a new matrix that has a new vertex. And the new X coordinate is going to be, the ABC row times the XY1 column. So AX plus BY plus C. And then the DEF row times the XY1, DX plus EY plus F. And then, of course, 0, 0, 1 is just 0x plus 0y plus 1. So, yeah, so with this, this 3 by 3 matrix can define a way that we can transform a point that is two-dimensional. And then, of course, we want to do a three-dimensional vector, then we do a 4 by 4 matrix. We just add 1 to that. Okay, so basically, the matrix on the far left is defining a transformation, the way that we're going to transform this vector. For instance, if we put 2 as A, so if it was 2, 0, 0, 0, 1, 0, 0, 0, 1, then it would just basically be like, okay, so it's going to be 2x, which means that wherever the x is, you're going to double that. It's going to be a scalar. We'll take a look at some of the actual operations we can do in a second. All right, so we can have a transform. Then we can have a matrix that's just where every column is a new vector. Well, if we multiply those, then what we get out is a new matrix that has these vertex outs, these vectors out, I should say. And so, yeah, one transformation matrix can define a transformation for an entire set of shapes. They're really, really powerful. And the other thing to know about them is that, let's say we have these 3 different transforms, and then our array of vertices. Well, we can kind of start multiplying from the left. So we can take those first 2 and sort of like multiply them into one combined transform. And then take that one and again multiply from the left again. And we have one big total combined transform. That means that we can take any number of transformations, combine them together into one, and it becomes really efficient. So if we have, a thing of 40 vertices that we're multiplying by one transform, we're able to just sort of transform is just hanging out, and we're going to be able to it's much quicker to do the math to make the smaller to multiply the smaller matrices together first and then the big one, rather than multiply the big one. If we had gone from the right, it'd be 40 vertices times the 3 rows, and then 40 again, and then 40 again, instead of 3, 3, and 3, and then times the 40. So yeah, that is okay. That's the theory part, and I'm gonna show you how this actually works in practice. So let's go to CodePen. And I'm going to create a new pen. And I'm going to create an object. Yes, of course, it's going to be a tomato box. I'm going to say that this is transform. And I'm just realizing I need to kind of get this over here. See if there's any chat, which there is not yet, but I'm going to put that in the chat. Okay, so let me make this happen. Again, we're not going to need JavaScript for the time being. Tomato box is going to be, width 2m, height 2m, border radius, just because I like that sort of thing, 0.5 m. Background, tomato. And actually, let's make this 5m. Yes. Okay, so we have that. And in fact, I'm going to take this and make this a linear gradient. This is another story for another day, but man, they're cool. 45 degrees, tomato, sky blue. I have a feeling I am defining that. Oh, I'm defining that correctly. Awesome. In fact, let me make that 215. Nope, that's too many. 135. Okay, so I wanted that right corner there. Cool, cool, cool. That'll help us visualize better what's going on, I think. All right, so now I can apply a transform. Yeah, so what do I want to do? Well, my base transform, my transform that means do nothing, the identity transform, we could call that scale 1. So that's scale, like, times 1. We could call it translate. One of the options we get is scale, translate, rotate. We could rotate nothing. We could translate by nothing. But let's do a scale by 2. Okay, you'll notice it kind of grows. In fact, I'm going to apply a transition to this 1 second transform just so we can see this happen. So if we go back to 1, and you can see it kind of goes by it grows and shrinks around the center point of this object. There has to be a transform origin, and in this case, it's the center point. So let's 2.5. You see that the whole thing is growing or shrinking. I can scale just on the X. I can scale just on the Y. All right. There's my scale. I'm going to put that back to 1. And I want to say now, let's do a rotate. I can rotate by 45 degrees. Rotation by 45 degrees. 135. 215. 305. 315 rather. Yeah. And then back to 0 degrees, and it goes the other way. Okay. And then another thing I can do is, skew. That one. Do I have skew? I'm going to double check that I actually have skew. CSS. Chat. Okay. CSS, actually, let me look at that on here. So CSS transform options. Yeah. Oh, let's look at CSS tricks. That's probably a better one. Yeah, I do have skew. Let me double check to see how it's used. I don't use it that often, which is why I'm a little bit rusty on it. So scale, skew X, skew Y, tilts a parallelogram. There's no shorthand skew property because, of course, it couldn't be. So it should be 312, maybe 1M. Do it by something. Maybe it's 10%. Oh. To be honest, they don't change much. So translate. Translate just means to move. Okay, so it's 10%. Translate by 10. So it's like 10 pixels or whatever my unit is. Translate X. Oh, I think maybe I have to do say actually the unit that I'm translating by. So 20 pixels. Now, another note, and this is an interesting thing, is percentage. We can use percentage, but it works slightly different to using percentage around anything else. So whenever I say percentage for any other for any other like value in CSS, for any other property, the percentage is a percentage of this item's parent. So if I said width 50% here, it would be 50% of its total available width on the page in this case. Or yeah. There we go, but now it's 5M. So, but here, if I said 50%, if I said to translate by 50%, it would translate 50% over of its own, of the size of the object itself. So this is the only one where percentage means my own percentage of my own size, which I think is really interesting. Okay, so let's talk a moment about, now I did that thing about combining. So we can combine these, which is pretty cool. So what I want to do is I'm actually going to make this, well, actually, before I get to combining, I want to talk about let me just say display inline block. There he was. All right, so let's take out change up my transform for a second. I'm going to put it back. And I'm going to make this tomato box there. Okay, so I have these two. Now, if I were to set the width of, here's all that stuff, display inline block. So I'm going to say, I'll switch this to SCSS for a moment. So I can, all right. So I only want to apply this to the first one. Now, what happens if I say that the width is actually supposed to be 10M for the first one? Well, it gets bigger, and it actually pushes this one over. This one now has a larger displacement. When I deal with things like width and height and margin and border and padding, it displaces, part of the box model is it displaces the stuff around it. But when I do a transform, it doesn't actually do that. If I were to say transform scale x by 2, what would actually happen is that its appearance would change, but it actually doesn't take up any more space. So here it is. Here's the size of it, but this other one just kind of fits right there. So this only affects its appearance. Now, it does affect the moving of stuff within it, but it's interesting. It's not actually, yeah, hold on. This should be, there we go. Right, so it doesn't affect the displacement. Okay, now we were talking a moment. Let me take out that second tomato box. All right, so I said that we could combine rotation, combine transformations. But, well, one of the things I guess I should say about math when it comes to geometry and when it comes to a bunch of things is that we are really used to the rules of what operations you can do with numbers. For instance, you can multiply them together, and A times B is equal to B times A, and that sort of thing. But when you start dealing with algebra, even Boolean algebra is a chance to look at a thing that, like a number, has operations, but they don't operate the same way. And matrices are an example of that. There are, yes, you can combine matrices, but you can't combine every matrix with the other matrix. In some matrices, you can only combine in one direction. And if you combine, if you multiply matrix A times matrix B, and you can combine B times A, that doesn't mean that A times B will equal B times A. And what I mean by that is, okay, so let's try to do a scaling and a rotation. So I am going to, I'm going to rotate first by 45 degrees. And I remember from that image As you might remember from that slide, technically speaking, the last thing I write in this list is the first thing that's actually executed. So first it's scaling, and then it's rotating. Well, what happens if I it's the order? What happens if I rotate it and then try to scale it along the x-axis? Well, now it has this sort of stretchy diamond shape. If I make that 30, you can kind of see how this distortion continues, right? What's happening is that it's distorting along the here. It's basically I'm rotating it and then I'm stretching it like it's in a taffy puller. So the order that you perform transformations matters. Okay, I've shown you only the ones for 2 dimensions. So let's talk about 3 dimensions. Now, oh, you skew by degrees is what you do. That's good to know. Sorry about that. There's skewing, by the way. And you can see examples on this in CSS tricks as you see fit. But okay, so what we can do, oh, can you do perspective as a, interesting. So 3D, let's make a new pen. Okay. I'm making a container first for my tomato box. Tomato box. Again, we're going to give it the same properties as we had a moment ago. Background, linear gradient, 35 degrees, tomato deep sky blue. Height 5M, width 5M, border radius. Okay, so now this is in 2D space. How do we make a 3D space? Well, what we can do is kind of create a container here. We're kind of basically what we need to do is we need to say of one of these things, hey, do we have something that is 3D? I'm going to say the container. And I'm going to double check that I'm writing this right. Yeah. Because here's, now we can get scale 3D, scale XYZ, rotate 3D, rotate XYZ, matrix 3D, perspective, and we have transform origin, transform style. I'll get to that in a second. Backface visibility. I think, yes. So we can say, hey, actually, I want to do 3D style transforms. So transform style, preserve 3D. Now, doesn't look like much has changed. Fair enough. But now I have the 3D things available. So I can rotate about the z-axis, 45 degrees. Technically, that's what I was doing before, right? Oh, and let's actually say transition. Right. that's rotated around Z, but I can also rotate around the, okay, well, it seems like it just got smaller, didn't it? In fact, let me kind of keep on doing that. Okay, got smaller. There it's, oh, it's technically backwards, so I guess it rotated. I don't know. This isn't terribly helpful. I think we can all agree. Doesn't really look like anything because it doesn't have a perspective. It has of projections here. So I'm going to add just a little bit of perspective. And the rule is that the smaller perspective, the more dramatic it is. And now I'm going to set this back to rotate y 0 degrees. Oh, come on, buddy. Yeah, rotate y 0 degrees. And we're going to see what happens. Oh, let me go to 15. Save this. I'm going to go ahead and, there we go. Okay. Right, again. So if we go to rotate y 0, okay, and let's go back to 180. See if you can notice the difference. Yeah, that was a bit extreme. Let's make it something a little more, let's make something a little longer, see if that changes anything. So there's 1,000 now. Okay. I'm going to slow this just way down. You take a look at it. So it's less noticeable there. Let's take it to about 300. Make the change, see what happens. Okay. So you can see that it's the red edge that's in front of us first, right? Yeah. We can also set where the perspective is. I think it's on a goofy spot, but so yeah. Okay, so now what we have is the ability to do things in 3D. If I wanted to combine this, maybe I'll say I'm going to say that hover transform is going to be rotate y 180 degrees, and then also rotate. Want to try rotate x 180 degrees too? See what happens there. Okay. Of course, it was just one rotation around Z. I'm a dum-dum. So let's try something a little more dramatic. 360. Now, it's just really kind of focusing on the 180 degrees there. Maybe I should make this 359 and see what happens. Okay. So now we got trippy stuff happening. So if we didn't write in perspective, the assumption is that it's infinite. Infinite perspective is the same as an orthographic or isomorphic presentation, which basically means are far away, that are the same size, look the same as things that are close to us that are the same size. So if you have two bowls and one bowl is across the room and you have the same size bowl in your hand, they would look the same. This is a little bit like the Age of Empires effect, you know, Age of Empires, where Yeah, you'd have these grids where like a house over there is the same size. Well, she would like to have that house over there. Let me see if I can find a good example of it. Yeah, where like every single one of these walls appears to be the same size, right? That is that is orthographic or isometric. That has no perspective. All right. And we could put in perspective, but sometimes you want to have no perspective so that you have things that look the same far away as they do closer. You can kind of click in on them. And there's something to be said sometimes for not being realistic. With this set of transforms, we are able to do all sorts of moving things around, which I think is pretty cool. In that case, I think I want to kind of do something a little bit more difficult. I want to set up a three-dimensional cube. So let's make that happen. Okay. Should be exciting. New pen. All right. So I'm going to start with CSS. It says WTF. Let's transform 3D cube. Okay. Yeah, and so I'm going to make a container, and the container is going to be kind of my 3D container. That's not how HTML works. I'm going to make kind of the cube itself, and then cube face color times 6. Oh, cube face. Oh, cube face. Yes, final answer. Okay. All right, so what I want to do with the container is going to be the thing that whose transform style is preserve 3D. And while I'm at it, I may as well, I don't know, I might as well, the body is position absolute. Yeah, I'm going to make just this, width 5M, height 5M. Black, that's not. Background black, come on. Right, and I'm going to say this is position absolute, top 0, bottom 0, left 0, right 0, and display flex, justify content, center, line items, center. That seems to have done it. Okay, so now I have this box in the middle, and this box is going to be, let's make width and height v min. Oh, sorry. Let's do it 50 v min. Okay. So now this is in the center. I'm going to take off the background. I'm going to make this position relative. I'm going to say of each cube face. So there's a cube here as well. cube, position absolute. Yes, I do want the cube. Yes, that's the thing. Oh, then I'm just gonna have this cube without anything. So every cube face needs to be position absolute, up 0, bottom 0, left 0, right 0. And then I'm going to say cube face 1. No. Background blue. Okay, so there's that cube. The cube face itself, I think I'm going to say just, all right, kind of at a jaunty angle. So transform, rotate about the y-axis by 10 degrees. And it makes the entire thing go away. Okay. What would happen if I did 0? That's interesting. Okay, I'll have to figure out what that is. Background blue, I'm going to say that I want this to, I want it to come out like 25 V min, whatever the kind of half thing is, and rotate, and just come towards me. So transform, and in fact, I might make a perspective of 1,000 pixels just for fun here. Oh, 1,000, 100. I want it to be too crazy. Oh, and maybe I'll make this RGBA, red, green, blue, point. Oh, or actually, I'll just make it blue and just have a slight opacity. Border, 1px solid black, or maybe 5px solid black. There we go. Okay, opacity 0.5. All right, and then the transform, I'm going to bring it way kind of half the width of the cube. So transform. So I'm going to translate Z. CSS transform, translate along the Z-axis. And I should point out that the Y-axis goes from top to bottom. So like this, the X-axis goes across the screen, and the Z-axis is the one that's coming right towards your face. So translate Z. I think that it becomes positive as it comes towards you. Yeah, that makes sense. So translate Z by 25 min. Okay, yeah, that's now closer to me. Cool. Then I suppose I'm going to make this one hello. And this is going to translate Z. Sorry, no, cube face 2. They're kind of right into the space, but I'm going to do this one by minus 25 min. So now I could, I wonder if I have to make this absolute 0. Okay, there we are. Rotate Y by 15 degrees. Oh. So I have that. Oh, it might be kind of clipping as it gets closer to me. That might be the issue. That's what we're going to see in a moment. This is exciting. So I might say rotate Y and then translate Z by, I don't know, 10 min. Minus 10 min. Look, I had it there for a second. Maybe. Oh, minus 100 min. Yeah, I'm not sure why it doesn't show up. We'll get to the bottom of this in a bit, I think. In the meantime, rotate X. What an interesting problem. Oh well. Doesn't matter, we can get to this eventually. Maybe I'll make the perspective. I'll make it closer. It doesn't matter. Anyway, 300 pixels it is. I'm going to take off this transform. As fun as that is, it's nice to know that I have my cube. All right, so there's that. There's that. I may tell it, rather than translate that by 25, now it's kind of bare. And then once it has translated that, then I want it to rotate about the y-axis 180 degrees. So this means that basically I took it out and then I kind of moved it to the back. Right? So basically I brought it towards me and then I shifted the entire model around to put it to the back. All right, so that's the bottom set. Let's do the green side. Background green. Opacity 0.5. Border 5px solid black. All right, and this one I'm going to, this is going to be very similar. I'm just going to do this, and instead of 180 degrees, I just want to rotate 90 degrees. So now that's on the side. What's meant to be opposite green is magenta, I suppose. So let's do that. Cube face 4. Right. This is going to rotate either minus 90 or 270. It doesn't really matter much. I'm not going to change it from where it is. And this is going to be magenta. And then top and bottom is going to be, I guess what I'm missing is red and cyan. So five. Not going to be magenta. This one's going to be red. And instead of rotating around X, it's on the bottom. Does it? Yeah, close enough. And then cube face 6. The red, it's going to be cyan. And so now that is at the top. Now the question is, can I get this to rotate? So what I'm trying to do here is I'm going to try basically I don't know why that's the only one it shows. It kind of collapses them. So what happens here. Oh well. Right, well, I'm not sure why it doesn't do that. Not thrilled about it, but that's it. Okay, so what I should be able to do is also apply a transform to the cube itself, which is containing all this. And then it should turn. It's not for a moment, not sure why. I'll get a chance to play with that later. But that is introduction to transform. So we have a lot of power with transforms, a lot of things we can do. So I'm going to give you an example of what one person did combining transforms. This is done entirely with CSS, which is pretty amazing. So SVG, things pop into place. As you click on one, this happens. All right, and so if we take a look at the, I'm going to sort of do this. So there is, there's a polygon with points. This is being held with an SVG, which is in some sort of level here. So we have levels and surroundings and mol. So we see here rotate X, translate X. So I'm wondering what happens if we actually made this 35. Okay, now we're seeing everything from the back. So we can see, let's go to 5. You can also see which one, where the transition was applied and where it wasn't. Okay, so yeah, so this is kind of an amazing thing that we can do with this. I hope you guys can come up with some stuff. I hope this inspires you. When we meet up on Thursday, I want to take the project we were working on, which has unfortunately become a meme generator about me, and use CSS transforms to navigate through it. Thank you guys so much. I will talk to you later.